Hello, everyone, and welcome to my stream today. Pretty excited about this one. I know I say that like every week, but we're gonna do stuff a little differently today. I would love if you came and said hi in the chat. Oh, weird, my audio is coming through the wrong device. Give me 2 seconds. I don't know what happened. It's coming through my speakers. Okay, check. Okay, check. Okay, that's better. Check. Yeah, I can. All right. All right. This one's gonna be a little bit different. Mostly that. How should I put it? I mean, you guys can decide if it's a problem, but I think I have a bit of a problem, and that problem basically comes down to the fact that I actually mentioned this on X earlier and Blue Sky or whatever earlier this week, and I'm going to start here, and then we'll get into the content today, which is obviously very exciting stuff, Solid 2.0, but it's actually really relevant, and it's important that I address you guys who are on the stream first. Sorry, I should also. Hey, Brandon, I should say hi to all the peeps in the chat for a second while I get this loaded up. But hey, Brenley. Hey. I wanted to address the stream regulars because you guys know how big of a release Solid 2.0 has been to get to RC. I know there's still a lot of work to go from going RC to stable, but a lot of the work that we focus on the stream is reaching its end. We did a good job, guys. But it also means that it's a bit of a hey Gabriel, it's a bit of a switch into tone, right? Hey, thanks, Paulo. He works with the Svelte team. Yeah. All right. Yeah. Thank you. I still first to stable. Yeah, I mean, but if we were first to alpha too, it was kind of like a back and forth. But only people paying attention to the stream probably knew that. I guess, yeah. I guess it wasn't alpha. We called it experimental, whatever. But yeah, and this is actually very related to what I want to talk about today. Just to address everyone before we get started, because you all are so important in things actually forming the way they do. I don't know if you realize or appreciate that, but being on stream and being able to talk through these ideas and getting feedback early has actually drastically shaped the final solution. I'd always come back, and it's not just direct feedback. It's me explaining the concepts, and then people going, "This confuses me," or "I don't get this," or "Ryan, does it have to be this way?" And that has been foundational. There's there's the stream tier, there's the Discord tier, and then obviously my feedback loop with the agents directly. But all three of these have contributed to what I believe, our final stable design is here. And this is really powerful, and it's why I am so appreciative of all you guys and doing this stream. The tricky part though is something that I just want to pull out right here. And Paul is right. Not that it really matters, lol. But maybe it does a little bit. And let me talk about this a bit. Give me a second. I'm going to pull up one of my tweets. Just to get this going. Share my screen. It's not shared. My worst habit as a framework author. I live far enough in the future that I'm never home when it arrives. And I felt this a lot when working on the Solid 2.0 release. Because from when I started the release, I mean, beta has only been 5 months in RC, but when I actually started the concrete work, it almost aligned exactly when I moved from Netlify to Sentry. Like the timing was almost identical. At Netlify, I worked a lot on Solid Start, the full deployable solution. And it's funny, it was where we wanted to be. It wasn't intentional. It was kind of coincidental that that's just what I was working on at Netlify. But it marked, like, my time at Netlify was like basically Solid Start, and my time at Sentry so far has basically been Solid 2.0. But the roots of Solid 2.0 started before that. There was a working group back in 2021, 22. I just had to prioritize things and kind of got derailed by trying to fill out the Solid Start story. And I think a lot changed over that time period. I kind of just went heads down, obviously not completely heads down because I have all you great people here to talk through all this stuff. But we started designing stuff right away. Like back in, as I said, probably mid 2024, we were talking about all this async stuff, right? Before anyone else was talking about this async stuff. And it's tricky because what happened since I started on Solid 2.0? I watched the other frameworks not only adopt signals, but adopt fine-grained rendering. We suddenly had Felt 5 come out in the middle of that, and View Vapor on the way, got announced and stuff. Server functions. This is another baby of ours. Ended up, I guess, a little bit earlier, ended up showing up in Next.js back in, I think they got them in 2023. I think they were only about a year after. But again, remote functions and Svelte, and Quick got their version of server functions too. I guess that was also back in like 2023. But single flight mutations, these are concepts that we built on Stream, 4 years ago, and we were already off to the next races. That when everyone started delivering on these features and making big hype around them, it just kind of got forgotten. I never took pause on what we had accomplished, because for me the goal was further, right? The React teams had this trap in the past, right? Except they handled it differently. Remember, they introduced suspense back in 2017, I want to say, React Iceland, and lazy, and then they had honestly, the story didn't finish until async React came out towards the end of last year, like fall 2025. And that's an 8-year gap. And they were kind of working on it in the background and stuff. And honestly, they inspired work. So to be fair, the first framework to actually really think about async in the shape that we talk about today was React. So React, big props there, right? But the challenge is that if you're always chasing the completion of that story, you're not here for, like the stuff when it's actually happening, when the developers are actually adopting it. And a lot of times, a lot of the features of Solid get overlooked because we don't talk about them. I talk about them on the stream, but people don't understand what it practically means for them. They don't actually understand what's exciting about it. And we get in this awful loop where I'm talking about something and it seems so amazing that people are like, you know what? I'm not going to use Solid 1.0. I'm going to wait for Solid 2.0 to come out. And I'm not going to lie, I almost did that to Solid 2.0. I almost came up, I was very tempted. I figured out some really groundbreaking stuff the last couple of weeks. I mentioned it on Twitter, and I was really tempted to just go all in on it today, And what would that do again? What we would do is we'd basically undermine what people can build today. And I know the stream has been all about that. It's all been about living 2 or 3 years in the future. Right? There's a reason that other framework authors watch the stream. You can see it in the chat. You can see it in the history. We're always plowing ahead. But it also leaves us behind. Like if you go talk to a Svelte developer about remote functions, they have no freaking clue that Solid shipped something almost identical 3 years earlier. So View Vapor, another one, beautiful, 7 years earlier. And you could say poor marketing on our part, but it's actually my fault. I get people so hyped about the future that we never stop to take, I don't know what the term, take value in what we deliver today. I have this terrible tendency to just keep on moving. So yeah, I think it does matter. I want to be here this time to actually celebrate in what we've accomplished, because maybe pieces of it are subtle, but the way it all comes together is in a way that I haven't felt so like so in the right place since when I first kind of came to signals and fine grained rendering back in 2018, or I guess it was 16, it was before that, but 18. The moment it came into click was when the React announced hooks, and then I was like, wow, people are actually going to do this. But it hasn't felt like that exactly the same way since then. And I think we're at one of those moments. Now is our time. Isn't Solid 2.0 represents not just you know another incremental adoption, or evolution here. The ideas here, as they come together, is a complete game changer. And it's difficult to express that. It's difficult to actually explain that away. Some people saw the announcement post and they're just like, yeah, that sounds cool, but why is it different? What does it do? Someone asked earlier this morning, I was responding, they're like, how's this different than Svelte async? And the ways are subtle, but incredibly profound. We have the benefit here, at least, of the fact that I told you we kept on chasing the future. We are actually at one of those natural points where all the pieces align, which I think is really huge, and it does come along a couple axes. So what does that mean for the stream today? What it means for the stream today is I want to talk about today a bit more, less about what's next. What's next is very exciting, and we'll touch on it a little bit later. But I think I'm doing Solid 2.0 a disservice every time I get too far ahead of ourselves. And what we have is pretty incredible. Okay, that's the intro. Just catching up with chat. I hope you still continue to build a React killer. I build a Solid killer. Yeah. I mean, this is the natural order of things. Solid 2.0 also offers a real opportunity for Solid killers to come out. I say that in the nicest possible way, because at a certain point, you cross a threshold from being minimal to basically handling everything, and between 1 and 2, we cross that threshold. React kind of had this problem where if you look at Redact or VNext stuff, they're actually cutting features in order to make it smaller and do less because people think they don't want those features. And sometimes that's a fair bet to make where you're pivoting, you're kind of like changing the base thing. You're like, I don't need all that. But like, even though Solid 2 is incredibly tree shakeable, I couldn't make it as small as Solid 1 simply from the fact that, as you can imagine, it just does so much more. It's and a lot of it's intrinsic, right? And I think that's really important to kind of understand, like the guarantees that it provides touch every piece. This is why, like, I love the data star people around, fat morphs are better than server function and so on. Because when you try and take the whole picture of the story, like when you try and get like the whole spectrum of what the solutions can look at, like, and also try and make them fairly generalizable or universal, you do end up with more. It's possible to streamline on particular vectors and be more efficient. So at the same time that we open ourselves up to specific solutions being more niche, Solid 2.0 puts us in a position where we're not a React killer, so per se, in like we're not trying to, like, I spent 1.0 trying to prove a point. I had like a chip on my shoulder. I'm like, we can do everything that React can do. I feel like we proved that point, all the way down to universal rendering, mobile, all that stuff. But Solid 2.0 was different. It was like, I don't care what React's doing. I want to leverage our system. I want to do the most possible with our system. And for Solid, that means signals. Signals are the core of what we do. And I guess that's a bit of a bet. But Solid, the signals are more intrinsic to it than any other framework out there. It's funny. People were like, remember like when all the signals stuff was happening in 2022, everyone's like, oh, Preact signals is signals. What's the best signals library? So, Ryan, you should export your signals library as a separate framework. And guess what? I listened to you guys. In Solid 2.0, at solid.js/signals is a library you can install yourself. But it's not what you expect. At solid.js signals is the largest part of the whole framework. It has the most code out of it. More than Solid, more than DOM expression, more than thing. It is the largest part. It is an absolutely massive library. Let me look at. I haven't actually looked at what it tree shakes really well, but I actually haven't looked at bundle phobia. Maybe we should look at bundle phobia for a second. Do we have this? Bundle phobia. This is like the not tree shake. It's the really solid. What's it? At solid.js signals. My guess is this is going to show up larger than Solid 1.0 on its own. Yeah. 21 kilobyte signals library, min zipped. 22. Sorry, guys. I mean, I go point your agent at it, Fable ultra code mode, and try and make it reduce the size. I've done like 10. I've done like that round multiple times. The reality is, this is the whole framework. You don't use all of this all the time. Actually, which version of beta was this? Okay, actually, you know what? I think there's a regression here. We should look at this. Sorry. Actually, looking at this, there's a regression. Oh, no, never mind. Beta is the same size. Yeah. No, my bad. Sorry. It was 13, yeah. So, yeah. Okay, yeah, never mind. This gap from here to here, when we went from 40 to 60, was basically the optimistic lane machinery, I think. Yeah. This version was fairly, yeah. And then all the tons of bug fixes and stuff, yeah. So, okay. Yeah, how's the breakdown on this? Yeah, so, yeah, sorry, beta and RC are the same. But I want you to understand this, because you might be like, damn. AI articles and talking about that, we'll talk about that in a minute as well. That's a whole other topic. Maybe I'll save it for this. We can jab it. I like this. I would say Solid has made a massive leap in providing grammar we need to express async UI as succinctly and intuitively as possible. Yeah, and we're going to talk about the meta framework into the framework thing too. It's actually all part of the same direction. Yeah, I got 12.5 before 5, but I should have missed on the yeah. So yeah, I mean the actual size of your builds are like a baseline solid application, like the Hello World, is still under 10 kilobytes broadly or whatever, right? It was 5 before, now it's 10. It doubled because I couldn't tree shake the thing. I'm big fan of tree shaking. All those guys who are all like, you don't need bundlers and build tools and stuff. I'm. It's funny because they're always like the really web standards kind of people that are always like, it's like you think they'd want their users to have the best user experience. Nuts to me. I'm definitely willing to throw the developer on a fire if it means that the end user gets a better user experience. But, but only in the term of the infrastructure piece, right? I think it's important that we structurally design frameworks in a way that makes sense and provide guarantees. That's why I'm big on signals. But what I'm trying to say here is signals are incredibly important to solid. And I know React's like, oh, I want to remind you of something where React was like, VDOM is just an implementation detail, right? Um, you know, we could change something later or whatever. It's that's kind of BS. I humor me a bit, but yes, their actual physical VDOM they have is an implementation detail. But any solution that React has that needs to follow that shape is going to be based on a re-render diff engine. It's the rules, the contract that they set semantically in the way that you author their code. They can't change that on you. This is why the compiler is so odd. I mean, it's beautiful, but it's also so odd because it's like still has to pretend like components are or parts of the code are rerunning that aren't. Like, you know what I mean? Like when they see side effects that are nested, they hoist them so they rerun again. Like it's because they are basically tied to their VDOM. They're tied to their concept that the component is the unit of change. So effectively VDOM. We had Dominic Ganaway, Creator Inferno, Octane on stream when he was working on Svelte 5, and he's called Svelte 3 a VDOM basically. And it's because under that same notion of React, like yeah, it's not physically a VDOM, but mechanically, when you think about how these things rerun and what the unit of changes, it's a thing. So like today, there are basically only two architectures. There's hybrids and weirdness, but you have something like Solid on one side that is just all in on the components, and all in on the signals. And you could say that Svelte and Vue are Svelte pretty much in the same line. Little small difference because where their compiler meets the components, they're a little bit more on the component side. And then Vue, today with the VDOM, but Vapor puts them squarely on kind of the solid side. And then there's the VDOM side, which like Octane falls under. It's not a VDOM, but conceptually, like architecturally, you're kind of on that side. It's kind of almost, it's close to a block DOM and it's more granular, but it's still the idea that the component and the state are entwined. Like we always agree that they entangle, but that the unit is at least a subunit of the component and it doesn't live externally. That's the fundamental difference between these architectures, if you want to understand it. And both sides have to make bets because they're viable approaches. I think Octane probably represents the peak of where that other side is. I mean, I thought Ripple did, honestly. I don't Octane with the React stuff. I don't know. Like, we'd have to talk with Dominic specifically about the details or differences to kind of see there. But on the Signal side, Solid has basically been the forerunner, because like that's what we're proving here. There's other ways to get around the same kind of ergonomics and different trade-offs, but this is the purest version of this. And 22 kilobyte signals library. Isn't that wild? Yeah, as I said, I I I I I challenge people to try and rebuild the same system. I actually had AI at one point build the signals library from scratch just from the tests, and it ended up larger, obviously. But I mean, are we surprised? I we made a lot of and slower. We made a lot of really key performance, like some of the sizes based on performance stuff. We made a lot of key decisions and architecture stuff early. The signals library and over the bug fixes has had a lot of AI impact on the actual writing of it, but the core structures were all handwritten. The architecture was handwritten, like the actual like mechanics and the layout. Over time, it's been shaped a little bit, but I'd be very surprised if we could knock and some. There's probably 1 kilobyte of this is probably just the tree shaking guards, too. They add like a little, maybe kilobytes a bit heavy amount, maybe 300 to 500 bytes of the tree shaking guards. So they do add a little bit of overhead on the whole thing on top to get the tree shakeability. But I think you'd be hard pressed to like the most optimal handmade code to knock more than maybe 2 kilobytes off that. How big's Vue signal library? Well, it, yeah, it's just not comparable. That's the thing. This is the whole, like, this is the framework. And this has important repercussions, though. And there's a reason why I'm starting here. Because it means that to teach solid, I need to teach signals. And we're going to talk about signals today because I want to make this addressable and approachable to everyone. This might be content that longtime stream users are completely familiar with. And I apologize for you because you've been you're the people that I respect a ton for being with me through this whole journey. But we have to learn how to talk about Solid 2.0 to the to the current devs, the people who are building apps. This is a challenge for me. I don't know how to explain just how incredible this framework is, which you think it should be obvious. But if you talk to the people in Hacker News, apparently I'm completely unable to explain what the value is here. And we got to work on that. So I think that starts with saying, like, hey, you're new to Solid 2.0. Here's what's going on. So we're going to run through a bit of that today. I haven't specifically thought about integrating Effect, though. I think our Actions API is like a sweet spot because Effect has a lot of very good work with sequential things, and that's where it fits. Well, we have a generator-based Actions API. If there's a way to go from effects like this, then this, then this, then this, then this kind of wiring into an async generator, like we're a match made in heaven. But yeah. What do we got here? I love your articles. Maybe Sol 2 came out right time when writing you is increasingly aging. Old habits mental carry the same weight. Maybe. Okay, yeah, it's just duplicate post. Yeah, I'm hoping so. I think there's a lot of good things in alignment now, and I think a lot of these choices are going to make sense um, as we talk about like what directionally we want, why we believe in signals. Why do we think this is the future? I mean, I think we've all seen. Well, maybe we haven't all seen. I want to pull up a. Do I even have it anymore? Code Sandbox is like dead, right? Like, can I even get into my old Code Sandbox stuff? Well, it's funny. I thought I would. Sorry, guys. Give me a second. All right. Thank God. Okay. So I used to have these solid examples when I released Solid 1.0. And there's this one example. It's such a silly example. I could probably just make it again from scratch, but yeah, it's funny because I have all these like suspense things, dynamic component hydration. It basically, yeah. Let's. I'll just make it really quick from scratch. Do this. Playground. I need to refresh the playground. There's a whole new playground that you can actually update to Solid 2.0 right here. And hopefully it all works. Yeah, there we go, Solid 2.0. Solid 2.0 is breaking, but the playground example is completely unchanged. It's breaking in a slightly different way. A lot of developers, like people who make toy demos, aren't even going to notice the breaking nature of it. But yeah, does my counter still work? It does. Okay. But one of the oldest solid demos that I did. Thanks. Yeah, no water. One of the oldest solid demos that I ever did was, okay, let's make function button. Let's just like put the button in here. I just this is so obvious to everyone at this point, but maybe you've never used solid before and you're not aware of this. And I should use TypeScript here, but I'm being lazy. I think you all know what I'm going to be doing here. Button, on click, increment, button, and we're just going to pass count through here. Okay. Sweet. Okay. So unsurprisingly, this should still work if I actually wired it properly. What's wrong here? Props type. Is it on click? Yeah. This is why you use TypeScript. I'm being lazy here. Okay. But my point is, okay. And then I do something silly like this, where I would do like console.log counter. And then I do something like console.log button, right? Okay. And you see it console log once, and then you click the thing, and it neither log ever again. And what used to throw people off in this example is I used to do something like count +1. Let's just start at 2 for some stupid reason. It still never runs it again, because the truth of the matter is, as you compose through the primitives, every expression basically becomes its own pipe. It's basically passes through without re-rendering any components. So this becomes a function that gets called in here. So we go straight from source through as many components you want without rerunning any of the components, right? And this decoupling of component from state is the fundamental piece that differentiates us from a model like React. No matter how big your app gets, no matter how you lay out the components, unrelated pieces are not going to update on you. or cause cause unrelated updates. React's compiler is designed to guard against this. Solid is literally just how it works. It's impossible. Like you can't mess it up. You don't need a compiler. It's literally structurally encoded into the rules of the framework. So I don't think this is news to most people anymore, but this decoupling is recognizing that state can be owned by a component, right? We can stick it in there. I'm just putting a fragment down here and adding a second counter. Right, now we have 2 counters. See, each component owns its own state. But if we want to, if we hoist the state out into a global, and I'm not telling you to do this, fun. Ha 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 ha. Oh, we're gonna have to play with that funny. We don't recover from reactivity right now. The playground's gonna have to account for that. We're a little bit harsher now on terms of like telling you that you did something wrong, but the playground doesn't use the HMR. It does like its own kind of thing. It's gonna need there's reset APIs, but it's gonna need to wire into them. Good to know. This actually makes it a little bit awkward. Because how do I tell it to refresh? That's interesting. This is why we do this stuff. We learn this. Refresh the page. Beautiful. Okay. Yeah, that's all I need to do. So you have these 2 counters. Now, I hoist the state, and now they're shared state. So the state can be owned by the component, but it doesn't have to be owned by the component. And if you look at it, we're still not logging each one more than once. So yeah, I mean, that was the solid 1.0 pitch. Yeah, I mean, looking at the chat, you guys are mostly solid users, so I'm like speaking to the choir. I was really hoping this announcement would get past solid users, because this is the moment in time when like we're at this rare place where I think we've cracked it, and I'm going to show you why today, as most of you guys might already know, but this same sort of superpower gives us so much information. Solid DevTools already highlights this a bit, but we actually know what updates tie to what updates in UI. It's a graph that can be traced, which means that like signals are incredible from an observability standpoint. This is like, they're incredible from a performance standpoint. This is why if your source is incremental or it's, has very small changes, like, maybe like a sync engine, you know exactly what piece of data changed in your database. You should be using something granular on this side to tell a complete end-to-end granular story. But more than that, we have the linking. What you wire incidentally through creating this UI is a graph. You're basically telling, when something goes wrong, you're basically telling the framework, you're telling the tooling what went wrong. Like, just go re-render it model doesn't know anything like that. So why does this matter in terms of like Solid 2.0? Why Solid 2.0 is such a big deal here? It's because by making async part of the graph, async is no longer a side effect. It's no longer some thing that happens outside the system that then gets like inflicted on you. It's not like, it's funny, in the article, release article, I called it a condition, like a medical condition, and that completely went over people's heads. And I'm sorry. It's just, I've been thinking so much from the perspective as the framework is a person. I'm way too close to this. Some people talk about how their AIs are people. For me, the framework's like a person. And I see all the other framework as it's like it's little buddies, you know. And async was like getting chicken pox. Um, it was just a thing that kind of happens, and then the framework's like don't scratch. It's this it's something that you're aware of, but you can't really explain where it came from, right? Like it just kind of shows up, you know. It's like I've used this in comparison before. It's like having like living in a 2D world. I think there was some Simpsons special from like 20 years ago that did this, and then suddenly there being a third dimension. Like you see when it kind of occludes into your surface, but it's not logical. Like you're just like, what is this doing here? And in the case for us, what that's meant is async is an effect, which means async is a write. And that is completely the backwards way to think about async. Async is a read. It's always been a read. It's always like, is this ready yet? Is this stale? You know, it's questions about, can I show this UI? Async can be writes and mutation, but at its core piece, async is a read. And if async is a read, how better to represent it than with signals? Because it's this problem all over again. That's the cell. If async is part of your components and you're re-rendering your components, like all it takes is having async in two components like this nested, and guess what? You're blocking this one, you're blocking this one, you know? You're playing this game of waterfalls. Right? Like humor me for a second. Like maybe this is a little bit too out of the box here, but just kind of like close your eyes, maybe, you know, let's just do a mental exercise. I mean, or you could maybe use your current code base. But like picture one value in your code. Just picture a section of code, and then you see one value in it. And today it's synchronous. It's like inside, you know, runtime memory on your client. And now it has to go async. Without redesigning your whole application or changing a bunch of stuff, how many files do you need to touch to change that one value from being asynchronously available to being async? Like that value could be like a list or a user or some kind of setting or something. It doesn't really matter. But like picture you have the value and you're like, okay, I have it today, but now I have to calculate something from the server to get it. You know, I need this from the server. Technically, you can go in there surgically and you can do a fetch and do an await or whatever right in that one spot. And it will probably work. But suddenly, you have to worry about two really, really important things. First of all, if you're waiting right there, that's where the loading spinner goes. Screw your designer. They don't matter anymore. Mechanically, I need to put the loading spinner right there because that's where I'm blocking. That's where I can't render thing. It's right smack in the middle of my component here. That's where the loading spinner goes, or above, arguably. But it wasn't async before, so I'm assuming, you know, maybe you already have suspense there, so good for you. Now it's triggering the parent suspense. Maybe that's what you want. Maybe that's not what you want. The second thing you have to be aware of is there any async below me? Did I just cause a waterfall? Right? Because if I'm fetching here, like, I mean, this is a stupid example, but if this was async button, don't ask me why this is async function button. This doesn't really work. I'm gonna have to do something about this whole thing. And now I'm like effectively await fetch something, right? And I also have async counter here. And I'm await fetch something here. And counter renders button, I don't get to run the button code before I get to, like you stop right here. Button is not getting rendered, which means it doesn't fetch. Then it continues. Now, you might be like, oh, that's why we don't have async in the client. We have wait in client. Well, we have use. Use. There we go. Now we have use. Let's use fetch something. But guess what use does? It throws. So guess you're also not continuing past here. I mean, how do you solve this? You can be clever. You can be svelte and you can like read the await and be like, if there's weights in my component, I can do some like smart things on how I kind of wire the stuff together by looking for where those awaits are. I might still kind of group them and it's a block because I don't really know my user's intent. But, because let's face it, if you have a component and it's like this, is it 1, 2, 3? Is it all in parallel? If this was actual JavaScript semantics, it'd be 1, 2, 3. But I think we're pretty safe to say by looking at this, 1, 2, 3 is probably not what the user wants unless, you have a situation where this depends on this, A smart compiler can wire that through. Or you can just not do any of this. Yeah, let's undo all of this. Sorry, this example is overworn its usage. I'm going to pull something up in StackBlitz. And you've probably seen this example before if you've been following the stream, but I think it's important for people who have never done it before. I already showed you that signals kind of granularly go through the tree. So the difference between fetch in 3 seconds being, I put it in here as the timeout, but screw this. Let's fetch immediately. Return, what does this return? Date now minus offset divided by 1,000. I'm missing closing brackets. Okay, whatever. Sweet. Let's refresh this. It looks like there's a rounding error. Doesn't matter. My point is, I'm in my app. I have synchronous data being worked at 3 separate points. Now it's async. And yeah, I'm sorry, it does take 3 seconds to load. But it's not a waterfall. It's parallel. And why is it parallel? Because it's not blocking. A is getting rendered into here. It has nothing to do with B. But even if it did, and we're threading the B prop, like through the props, like I showed a moment ago, it wouldn't matter until where B actually used it. That's what blocks this expression, not the whole render, not the component. Like we already have the read semantics that you want, and we get them for free. You don't need anything special here. A here is a accessor string. And guess what? I guess this is a number. My bad. Yeah, the number, whatever. If I'd string cast it the same way I string cast. Yeah, sorry. You know what? I missed the two fixed two. This is what we're missing here. This is why my example was not equivalent. Okay, and this is fake because there's no return. Okay. There we go. Better. So our sync version is accessor string as far as the application is concerned. And our async version is also accessor string as far as the application is concerned. So what I'm getting at is, yes, async has a cost that's unavoidable, but Signals gives us the perfect way to provide the guarantees of the graph without disrupting the way we author code. Yeah, so I'm catching up with chat now. Yeah, solid dev tools. I mean, for one, we haven't updated them for 2.0 yet. And here's the thing. When people focus on the granularity, they focus on performance, which is good. You should. But it's the authoring experience. It's only the dependence. Like it's basically this we can't avoid waterfalls, but we can avoid avoidable waterfalls. You know, I was once quoted at a talk saying like children become siblings, because that made a lot of sense to React developers. But to a human, I think you know, like someone who's not just a React developer, the logic here is a little bit more straightforward. It's just we avoid avoidable waterfalls. Don't get me wrong, you can still definitely wire in waterfalls if you're trying to, but there's a certain shape consideration here, and this part I think people get. And actually, Svelte has a great version of this demo because they can use their compiler to do pretty genius things. But no framework has a version of this demo that's as ergonomic. So this is one of those, like, this is when you start seeing the payoff, because the loading. Sorry, I should go back to the other example for just a second. But the loading is movable. Now, don't get me wrong. Where is it? It makes sense in this example that the loading wraps the topmost component because you're waiting on it. But this loading here is movable. First of all, we can remove it. The problem with removing it, you'll get a warning in dev on the client at least, but removing it still works. You just got to wait 3 seconds because there's no loading fallback. We just hold the render. It's basically, you know, so like that's bad experience. If we have dev mode in here, async outside loading boundary, async value is read outside loading boundary, the root mount will be deferred until all pending state settles. Yeah, so like be aware. But this is actually only client-side thing, because on server rendering, if there is a loading, if there's no topmost loading, we just wait to flush, which means that everything above the topmost load, it's PPR, you know, everything above the topmost loading basically renders without the fallback, like it holds, and then that's the point in which we flush the stream, and then the client can hydrate at that point. So it's like, there's no problem. This is a client-only concern. But the idea here is, it's wherever you really want the affordance to be. So if we, like, these all fetch in the same amount of time, so it's pointless for me to put the loading boundary down here around B and C, because what you're going to see, obviously, is it's going to be blank for 3 seconds, and then it's just going to show up with no loading because they all load at the same time. But like, if for some reason this used a different API method, don't even want to make it. You guys get what I'm saying, right? Fine, I'll make it. I'm just fetch in 2 seconds. And then this became fetch in 2 seconds. Fetch time in 2 seconds. This is gonna fetch time in 2 seconds. Then what you're gonna see is 2 seconds of blank, and then the loading come in, and then yeah, I mean the affordance, the loading didn't get its own div. It's like sitting right here, but you get what I'm saying. I mean, we could also keep the original loading around this. Sorry. Loading top, you know. You know, like, and then you're like, oh, you know what? We don't want it around B. We actually just want it around C. But actually, then we'll have the same problem because B will then cause the outer one to wait the 3 seconds again. Like, I hope you understand what I'm getting at is you can just kind of stick them wherever makes sense. It's like the async part is the data, the loading is the UI affordance. These are related but decoupled. It's very similar to the component decoupling that I showed with the props, and I'll give you one more example here on that side, because as I was saying before, you basically can't. Let me share this one in chat. You basically can't make this example in any other framework today. Now, do you want to? I don't know, but this is just naturally falls out of this. This is like a stab at React, having a state update in here at the top level component because it triggers re-renders. Obviously, their compiler can handle it, but this is just, ignore it for a moment. It's just showing that while this is updating, nothing else updates. The other thing that demo the last demo I didn't really emphasize, and I should have emphasized this, they all said rendered one times beside them, because even when we're trying to render a loading and then we realize that we bail out, we don't throw away the DOM nodes that you were already loading. You know how like React throws and then it's like, okay, we got to re-render the DOM, re-render our tree again. Solid actually renders as eagerly as possible, actually rendering most of the UI that it can't show. Like, it can basically render the pieces off screen and then it just attaches them. So even though this gets interrupted, we only still render the component once. That's the same kind of mentality here. You don't like, that's why you see this one time, even though if you look at this, like outloading, it's still 1x. There's a funny little thing that I'm using to kind of keep count of how many times each one loading. But why is this example important? We're fetching our number, and then ignore this counter for a second. This is just here. We pass our number through our components, and we're adding to them, kind of like what I was showing in that previous playground counter, where I'm like adding to it. I'm actually morphing it. But because, as you know, with signals, we're not evaluating it here. We're actually evaluating it, down, actually not even here and out. We're evaluating it all the way down here. We get to compose naturally, right? Because here's the problem. Remember that mental exercise we were doing a few minutes ago, where we made the one value async? If you actually wanted to solve the loading spinner here problem and the blocking here problem, the right solution, and like the async children solution, the right solution in most frameworks is to lift the fetching higher, put it in your route preloader or loader function. That's the best place. Get that fetching as high as possible, because now there's no waterfalls. Great. And then the affordance, get it as low as possible. Wrap just the thing that matters. Great. Now we have like more UI, less cascading spinners. Good. We solved it. But what happens to how I asked you earlier how many files you touched when you made that one value async. And I said in Solid or in most framework, like I said, like your starting point is probably one component, right? But in reality, if you do the right thing, it's every single component between the fetch and where you use it. Because now it's promise of user. You have to go through and basically asyncify your whole component tree. This doesn't care if this is async or not. If it's async, yeah, we show an affordance, but otherwise this is ignored. And the reason I made this a diamond is because this is where it gets really fun, because these are two separate paths of value evaluation. Think about it. If you're passing a promise, how do you +1 or +2 here? How do you tell double and triple or ×2 and ×3 here? How do you tell these that they get different values along the chain? I can't go into out and give it the good value, because your first thinking here is like, okay, I'll go into the lower component and just await here and do the ×2 or the ×3 down here, or do the math down here, right? Block low. That's good. I'll wait in here under my loading essentially, and then I'll do the transform. But if the component's shared, you have no choice. If you're using values in multiple places, it's the same reason you hoist high, right? It's because you need the value in more than one place. Generally, that's another reason why you hoist high. Once you mechanically building UIs where you need to share components, share values, it has to compose. And yes, I can compose this as promises. We'll pass the promise down, and then we'll be like, p dot then, no, we'll put the v equals v +1. So we'll go through and essentially tag thenables onto the end of each transformation. And then here we'll go props num, which is now a promise, dot then value v ×2. And actually, these are generic components. They might work with number or, so it's actually number or promise of number, to be fair. So we can't just do this. We actually have to check now. We're going to be like, okay, props dot num, maybe we could say instance of promise, or maybe then in props dot num. Num's a scalar though. Like, can we do in on it? I forget if it fails or not, because it's not an object. Whatever. I don't want to worry about that. I don't even know the answer. So I might know the answer, but instead, I'm just going to use component props the way I have always used it, and not touch every single component in the tree, just because this has to now be async. Is this a good way to explain things? Like, help me out here, audience. Are you starting to see why async in Solid 2.0 is more powerful than you've seen in any framework to date? I'm really relying on you guys in a completely new capacity, because I'm having really hard. I think this is amazing, but I'm having really hard time explaining it to people. Oh, what I said wouldn't even work in React? Oh. It's nice, but I think it'd be nice to let yourself as well, like a real React example. That's what I was trying to show. But I think this is kind of where the problem is. You can't create new promises during render. Right, because it could re-render, and then you referential equality. Like, React's compiler can't fix that. I guess I could use. Could I? Oh no, but I. Oh God, that's annoying. You might be like, oh, use ref or use some kind of like stable thing, but React's doesn't guarantee that stability stays over async. It's part of its like concurrency thing. So like you can't, it won't, like, it's the reason why you can't just use memo as a cache for React. What I showed should work for Svelte though. Like with doing the promise chaining, they can do that fallback. Like, it's funny because I did a comparison on this computer where I got different frameworks to do MVCs, and this is the challenge I've been having because it's like the solid code wasn't only shorter, it was more complete. Like what AI eventually started doing was just copying what I did in the solid example back into the like other framework examples, and then like adding their own infrastructure to try and make it work the same way, because their intuitive approach that they took to the other frameworks was had a bunch of bugs in it. Like I actually showed it this on a previous stream, and I think that might be a good talk when I want to compare to other frameworks. I'm hoping though that this in itself, this sort of example in itself, can showcase the power here without having the result to like saying like none of these other frameworks do it. Because who knows? Maybe one day they do adopt this and do this. Like Svelte, it's close. I think they've already kind of made a bit of a bet against this. They'd have to redo a lot of their async work from scratch if they were to actually follow suit. And I don't think they actually believe completely in where we landed. Like high level, we agree, but I also think that's because they haven't seen where I'm taking this next. That's fine though. Solitude delivers someone React prompts in React Iceland. Maybe. Yeah, I mean, that's the thing. You guys, somebody can do the exercise of trying to design it. This example is a beautiful example to try and design because it shows the composition principle on the read side. I actually did a post and nobody, well, especially people on Reddit, but no one understood what the hell I was talking about. I did it on Twitter too, but Reddit's probably the quicker way for me to find it because I know exactly what I'm looking for. This makes a ton of sense to me, but does this make sense to you? Yes. Solid turns expressions to lazy thunks, making it possible to treat async values simply as sync ones. Yes, that's probably the narrow, clean version of. But for people to understand it, I almost have to start with sync thunks like this and make my way to async ones. But the real problem is that there's 4 life cycles that happen in async when it interacts with your framework. There's the create, like when you actually do the fetch, like create the promise. As Gabriel said, you can't do this in React during render. It's like you're going to get wonky stuff. That's why they have cache solutions. Well, that's why you have to invent a cache solution for them. Then, but run once frameworks like Vue or Svelte or Solid or Remix don't have this problem. But where that comes back in is the consume point, like the await, the use, is coupled or like has this interaction with like the UI blocking part. You have to do this below where you do this. Boundary has to be above the await in Svelte. So that has to be above the use in React. That has to be above the whatever Vue does these days. And then the place that actually needs to be blocking is the read. And when you couple these things together, which is naturally what the JavaScript language does in a sense, right? Await async function. Do you see what I'm saying? Like this is like the async function wrapper around the await. This is a natural pattern. But what it means is the easiest thing you can do in the world is do it at the same level. Change one component, like I said. That's what you do. You realize something's async, you just change the one component. And the gap between where you should be fetching, higher up, prevent those waterfalls, and where you should be blocking, lower down, right around where the actual widget is you need to use it, is a negative on both sides. And you can play that toggle up and down. It's a dial, Remix loves talking about dials. But as long as these are tied together, you're going to be sacrificing DX or UX. You can move the dial up and remove the coloration so you don't have to pass promises through and do the composition. You can await or use are really high. But then guess what? You're blocking the whole UI. So you made the user experience worse. You can pull that dial all the way down so that you're blocking just around the read, which is good for UX. That's exactly where you want. But you had to touch every component in the middle and lose that composition aspect because now you're talking in promises. This is just like one of those fundamental structure things. And in Solid 2.0, we just break the chain. We just, separate the poles. And it means that this choice, like how far you want to move it, yeah, okay, maybe blocking UX isn't good, but maybe it's a design aspect, right? Right, we're not actually blocking, it's just a UI block. But the choice, this and these aren't necessarily fused together, but are kind of fused together. And this is wherever it makes sense for your designer. This is what I've always loved about Solid's design for granularity is it puts the power back in the UI designer's hands. You're not trapped because the framework makes you do something, mechanically. It's like sometimes, designers like, I need this to be here. This is where the loading indicator goes. And the framework's like, yeah, that's not easy to do. And you're now the guy suffering the DX part of the async coloration. And for those who don't know what I mean by coloration, I mean the null checks or the passing the promises through. It's this kind of contagion that happens when, again, this is what I'm talking about, async inflicting or a condition or like an illness on the framework that infects the whole component tree between where you actually introduce the promise and this. And you're like, oh, use context. And then you're not feeding it through the tree. Sure, use context. But like, at a certain point, you're going to consume it. And at a certain point, it's going to be shared. And you don't always get to make the change at the leaf. Like sometimes the leaf is the shared part. Don't worry. Like you can kind of do well enough with the other solutions, React, Svelte, Vue, or whatever. Like, I'm sure you can make it work. I'm just saying that this just does it automatically in the same way that fine grained has always just done it automatically. It's just a structural truth. Okay. So that is not even the full story, but that's like the first half of the async story. That's the part that I put in the release article. The second half, let's move on. The second half of the async story for 2.0, there's actually 3 parts. And they tell a beautiful story. But the second half is the right side, because reads are beautiful. I mean, I guess I'm missing one part of the read that we don't see in this example, and I'll just pull up a different example. I didn't modify this one at all, did I? Whatever. I'll bring up Ryan Florence's state demo. People have been watching this know that I've seen this demo before, but the last real part of the read demo, and this is another one of those demos that I encourage you to remake in your framework. Svelte does a beautiful job of this one. React is okay with async React, but it's a little bit tricky. But essentially, this is a drop down where when you change the state, we have to load the specific cities in the state. And the key to this demo is while it's loading, we don't want Florida. We don't want to ever see like Los Angeles, Florida. You know, like when I switch to California or Miami, California, we don't want to see Miami, California here. We want it to actually apply the change together. So like, obviously we've been showing initial load, but what happens after initial load? Now, the naive approach to async that we've seen in the past, with like, I don't know how view suspense works, but with React suspenses, you're always constantly snapping back. You know, like the default behavior is if someone triggers more async underneath you, we're snapping back to loading. Like I change this, loading, change this, loading, change this, loading. And honestly, that drives developers kind of nuts. I think like those kind of pain points are almost what led to Remix 3. Just like simply on the basis of like the async features, like sometimes you're loading, but sometimes you're not loading. You know what I mean? And the key to Solid 2.0 is, yeah, loading states are kind of like a one-time suspense. There's a way that you can like trigger them again if you really need to. Like on a key, there's an on prop. You can go on equals, like if you really want to make it that whenever the state changes, like on, what do we got? Selected state. I think if I change this, we'll jump back to loading. I mean, there we go. React preserved. But like, you don't really want to do this. The way the on prop works is essentially what I like about it is it's not inverted. It's not the way loading or suspense works. Is it's like an inversion of control, which is beautiful. It lets the async be defined not top level above you. It lets you define it by what actually happens below. And on doesn't actually cancel that capability. All it's saying is that when this changes, be perceptive of future downstream async changes. That's all it's saying. It's not like this is directly what triggers the fallback to happen again. It's what says, hey, you are allowed to show a fallback if something fallback worthy happens underneath here. That's the gist of it. But we don't want this. I just want to show that you can still do it if you want to. Now, the point is loading runs once. But you see when I click this, oh yeah, sorry, this is my this is running on like an old version of, this is like one of the beta releases. I don't even have Vite in here. This is an old example, okay. But my point is when I change this, see how this grays out? We still have an affordance. It's just not loading. We just grayed it out. And the way we did it was actually really simple. Is pending. It's pending cities. If this was a reusable component, it would be is pending options, because a component might not know what the data is that it's operating on, but it knows what it needs. Remember I said at the beginning, reads are about like, is something happening? Like is it stale? Is it not ready? That's what reads are all about. And so when you build UI, even generic components, you can, if you want to show an affordance, now you can obviously not do the affordance. A lot of times the UI components are kind of dumb, and then the app is responsible for the affordances. It gives more control to the app developer. But if you're building reusable components that have async in mind with async affordances, you can ask the question, you go, are my options not ready? If so, disable me. It's a generic question that can be generically answered. And because is pending is not really a value, but it's a query. You're asking a question. And that is super powerful because, again, we have a data graph. We can answer that question. Async is part of that graph. We know this. No other framework has this capability today where you can ask a specific question on a piece of data in your graph like that, right? It's just useful because, you know, some things change. And this is the story, right? You set up a loading, you set up the main affordances, and then as you're interacting with it, yes, there is a second affordance for pending, and often there should be. Often you don't rip out the whole UI because something's updating. You just show like a little micro spinner here, or, gray out this little bit here temporarily. You don't go like, all right, you don't go on Twitter and just be like, I did a post, whole thing turned into a loading spinner again, right? But that's the default behavior in a lot of frameworks. As I said, big props to Svelte for that not being the default behavior. And on a simple example like this, Svelte can use effect $sign.pending to basically indicate that like the action's happening, and they can give you the exact same UI. So again, it's doable, but this is the actual pure form of the thing. And what you don't see here, and this is like the killer feature, is how did the UI hold? What, we didn't have like a visible city or whatnot. Our state graph's right here. Look, we load the states in a memo. We set the selected state, and right now you're going to see one of the new features installed 2.0. We have a signal that takes a function. It is a derived signal. Someone earlier in chat asked if you could fetch state in a signal. You could. And then you could like overwrite the fetch data with a set state. I don't really recommend doing that. I think you should view the server in this case as your source of truth. So like a memo is the perfect thing. This is why like people are like, if signals can be memos derived like this, why do you still have to create memo? Why don't you just delete that too? Just delete everything, right? Create single, create store. We're done. Maybe create effect if you feel like punishing yourself for no reason. Like, why did I create memo? Because I think it's important to establish, even just semantically here, that like this is derived, and because this is derived, you cannot mutate it. This is important. The mutation is special. It's something it's a privilege. This is why we have separated like tuples here. We didn't just like give people like they can just write the signal anywhere thing, because it's a contract. It's an understanding. If you just make your state writable wherever, you know, like you're not giving the person who writes the code isn't giving future developers or API any intention. You're not saying like, hey, it's like the const keyword. Const is important. I know it's not read only, but it's important to understand what it means. And here it means that I trust the server to be the source of data. Server is the truth. Get states coming from the server. Then my signal is a ephemeral override. It derives from the state. So it defaults to whenever the states change, it loads the first one. Now, in this app, we have no country selector, so this is kind of mute. But so this only runs once. But then similarly, our cities are another memo that are derived from the selected state. Again, these are async, right? Like promise of string array, promise of string array. But as far as selected state is concerned, this is an accessor of string, and this is an accessor of string array, right? Or sorry, these are both accessors of string array. I was hovering the wrong thing. And then our selected city, again, is the first city when it loads. But then obviously we can override it with our temporal one. Basically, whenever this changes, it's the source of truth, but we have local overrides. This is like half of the freaking when not to use create effect docs in React. This just happens naturally here. You don't, like, we just killed, between the fact that you can fetch directly in this, like that there's no effect for fetching. This is just literally async function. And the fact that this is writable, we have just removed 90% of your use effect just in this one little example. What is use effect? Like, don't get me wrong, there are use cases for effects. They're just not for synchronizing state. At least not from, unless the source is coming from like the DOM or from something outside the system. This is why, you know, I remember Remix a couple years ago being like, when I use Remix, I never need use effect anymore. And this is like, when you set up your system, or I guess a better example, when I use React Query, I never need to use effect again. It's because when you set up your system to derive the data like this, use effect just kind of disappears away. And the fact that async is just part of this graph is just a wonderful blessing, because we get to know more. Whenever you have an effect, you leave the graph, right? Like if I make an effect here, it's kind of like the set count, right? If like, let me think here. Like if I go create effect and I go, I need another driver to do this. So this isn't the best example. But my point is, if like pretend, actually, button is a better example. Pretend for some reason the button wanted its own override. So it does something like const create const let's call it count again equals create signal props.count, right? We don't like doing this in solid already because we know that this could be a reactive value. ESLint is telling us like, hey, be careful, right? Why is it telling us to be careful here? Because we have false positives here. That's funny. I didn't realize this was actually a warning. This is actually fair criticism. I honestly am so used to this in solid that I never even think about this, but I guess this could trip people up. Good you ESLint people. Okay. Anyways, my point is, if I have a local version of count, let's say, and I use create effect, say like set count to props count whenever props count changes, right? If I do this, I basically broken the graph because I don't know, like this is not reactive, so this could literally be gone right there. I got rid of our warning. This should work roughly the same. I guess technically it'll render with nothing first. I haven't imported create effect, so and we're not using it, so don't worry about this error here for a second. But what I'm trying to say is, and this isn't even the current. Sorry, this isn't even the current solid create effect API. So props.count. Count. Let's do this. This is actually better. Actually, no. Look, we can be even cleverer than this. We can actually say set count. There's actually something like really symmetric about this, but my point is, we don't know what sets count. So count, we have no clue that props.count is associated with this value. If this ever went async, anything downstream of count here doesn't know that. Because we broke the chain. Like, it's not derived graph, it's literally a write. This is why async is so important in the graph, because it literally, all those places where we broke the graph before, where we lose our traceability or our observability, is no longer the case. We literally can, like in the case of like maybe like a full stack, fine grained thing, we could probably trace from database table update all the way to field in the UI, because it's all just async along the line and we create the graph out of it. This breaks the graph. This is why, sorry, I didn't spell it right. This is why we don't want create effect. And it's not even good. Like, the solution isn't good because it initially renders without any value, and then you kind of do this, and then you're like, okay, but then that's not good. The answer is like really easy. You just do this. Done. So I think this is a super powerful piece. To be fair, I first proposed this back in the working group back in like 21, 22. And in between me proposing that and us finally launching it here, it's shown up in Angular, it's shown up in Octane. I think they used linked state. Like the linked state thing is this idea of derived state or derived signals. But when I was looking at the problem, I was like, and this is part of why we're less tree shakeable now, because instead of calling it linked state, I just said, look, if you want a signal, you want a signal. This is a place where the API collapse makes a lot of sense. Like, are we going to have create memo, create single signal, create writable memo? Like, the problem, you start getting these permutations because there's also store-based versions of them and optimistic versions of those. I was like, no, you know what? Screw it. I know it's not quite as tree shakeable, but there's a simple concept, which is memos are pure, signals can write. Signal can also be derived, sure, but the important part is the write. The important part is what sets it apart for a signal is that it can be mutated. That's what I was saying. And that's why the contract is important. That's why the difference between these is important, because we're saying like, look, this is the source of truth. This is saying Yeah, I have a source of truth and I can override it. Yeah, you can work around stuff with use transition, use deferred value in React. Yeah. But guess what? If you're a React developer, you're gonna find this amusing. Every single set state or set city call in Solid is a use transition implicitly. This is why composition works so wonderfully, because when you write your component, like Ricky went around about a year ago and he was like, okay, guys, we need to have actions, like click action. We need to go through and rewrite all our component libraries for async React. And honestly, if everyone did that, I think React would be a lot more awesome than it is today. I think async React is actually pretty cool. The problem is, who's going to do that? I mean, I was like right on board with Ricky. You can watch the stream about a year ago, like in the fall, and I was just like, but then when he demoed it to me, it was funny. It was him demoing it to me that made me go, crap, we are really falling into a trap. And then I looked over and saw what Rich was doing in Svelte async. And I was like, I was skeptical of this before, but this 1DX piece is the release here, right? Like this is the thing that frees it up. And I was like, can we do this in Solid? Can we make a, because they get so many, their compiler makes things so easy. We don't have a compiler. I'm like, can we do this purely runtime? Can I come up with a transition system that works implicitly, always on, without taking a performance hit? And the answer is yes. And we did. And that's what we just shipped. It's funny because you go on a benchmark and you look at like when React turns on transition mode and it's like drops like 20-30%. I mean, we got to go to the RC of the JS framework benchmark, but I as far as my understanding is where it is, and the difference in Solid 1 and 2 is within the range of run difference. It's possible that Solid 2 is like 0.001 slower than Solid 1 on average in a benchmark like that. Like, but that's within run variance. So like by hunches, it's like the tiniest bit slower, but it's not provable by numbers. And and that's in that specific benchmark. We've actually improved numbers across the board in reactivity speed, and a whole bunch of other benchmarks. Store-based stuff and reconciliation way faster now. So it's basically not moved from like an averaged mean perspective. It's not anything anyone will ever notice. But my point is, without a compiler, this is just a property of the async system. And I think this is really important. So now I've completed the read part of the story. This is why this system is so powerful, because you get that consistency. You get held updates with affordances that are queryable at a per location basis. You get derived state that's async, that's overridable in a way that you don't need effects anymore, pretty much at all. You don't have to worry about your initial loading affordances hijacking your app in terrible ways. You literally just write what you think you would have to write, and it just works optimally. No early blocking, no waterfalls. It's just what you see is what you get. There's no solution out there that does this. I can straight up say that comfortably. Yeah, exactly. Link signal. Yeah, that's what I was talking about. The override here is actually really quite simple. This isn't even the complicated override. We'll talk about those in a minute. The override here is simply the value, right? The derive, we have a computation here. There's basically like a memo inside, and then we just update the memo's value with the state rights. And then whenever this retriggers, it takes precedence and rewrites it back again. It's not terribly fancy. The only piece is there is a little bit more coordination because we have the async bit. We don't commit changes immediately. We wait until everything resolves. But in basic, that's what's going on. The solid dev tools for 1.0 had them, where it literally lit up the whole tree and showed like you can actually like click a button and it would light up the changes along the dev tools. I don't know if work has happened much recently there. Solid dev tools, the Tarnav, yeah, great stuff. I actually showed this once on a talk thing because he's showing the component tree and then he has a bunch of ID'd values. There's a Chrome extension for it. The truth of the matter is, yeah, this probably hasn't been updated in the last, like, yeah, 11 months ago was probably the last update. No, 7 months ago. Package versioning. Kind of been waiting on a RC 2.0 before we move here. That's like where a lot of the work's happening now, around linting tools and like supporting tools. You saw the little bug I found in the playground. We're gonna have to like figure out how to make like some of the tooling stuff is still kind of in flux. Oh yeah, sorry. In my example, let me just post this in here so you can all look at it. My bad. I should have done this earlier. I it's right now I'm just using an async function here. This is just literally simulated on the client, but you could pretend this is your backend. You could pretend this is a server function, which we'll get to in a minute. But essentially, this is just some fake backend with a simulated response. I just had it in the file lower down, but the idea is like this is an API call. But it, like from our perspective here, it doesn't really matter. That's an API call. Without loading what selected binary, well, you just wouldn't see it. I think I showed this a minute ago. Without loading, we wait, and you get a warning. See what? Nothing. Oh, there it is. We're always consistent. I don't mind this because I think you can kind of tell. You're like, oh crap, there's no loading indicator. Like if you do the most basic thing, where you insert async into your app, you might have HMR on and not notice at first. So like let me show you. So let's say like you added, you're like working on it and you add the async. This example doesn't have HMR, but pretend HMR is on and you don't even notice. And you're sitting there and you're like, okay, yeah, this works great. This works great. I was going to do this with a Learn with Jason if I ever got a chance, like do some kind of thing and like be updating in real time and then be like, okay, yeah, so we made our app. That's sweet. We just add the async, easy. And then we'd refresh the page and we'd be like, oh, what's going on? Why is it blank? And then you're like, oh crap, I forgot the loading thing. And your hope is you're like, okay, where's my loading thing? You just go, the reason we rename this, side note, for human language, because it's exactly what you're looking for. I don't know what a suspense is. I mean, I do know it's a technical term for holding the rendering while async is processing. We suspend it. But if I'm a user and I'm like, oh, I'm not showing loading. I do the same thing with error boundary, like making it error or whatever. Like there's error and there's loading. You know, I'm hoping this is human findable language. I know that's kind of more of a view move because they're big on those kind of ergonomics. But here, this is good. There's some debate to call it placeholder, but placeholder already has meaning within like the specific elements in the DOM. So I'm happy calling this concept loading. We have no other concept in Solid that directly maps to it. Yeah, I mean, there's a reason I drag my feet at the beginning. People always get on my case for making betas really, really long or doing like multiple betas. Like at Solid Start, we did beta 1 and beta 2. And they get, you know, they're like, God, why Ryan is so slow? He never pushes the button. And honestly, this is a fault of mine. Solid could have gone 1.0 in 2019 around the same time Svelte 3 did, but I waited 2 years because I want to solve SSR. I wanted to make sure SSR was good. And in a sense, we got there, but it meant that we came out 2 years later. Similarly, I wanted to make sure this async story was completely fleshed out for 2.0. So the truth is we've added a few extra APIs and a few options in the last month or so, but the actual core API, like I'm showing you today, you can go find a stream from me 6 months ago and it hasn't changed. Like it almost didn't even change during beta. I'm just very conservative because of that. You probably like there was behavior changes in beta that's enough that I wouldn't have said you do production on that. But we're good. This is when I said it's RC, I mean it's RC. Do we get up and update the signal locally to the refreshes? I mean, the problem is you can probably update it. You're just never going to see it. Do you know what I mean? Because reading it basically like suspends because it's uninitialized. So like good. Extremely smooth. I understand the game changing part. Cool. Yeah, because this is my problem with explaining it because this is game changing part 1, and I feel like Solid 2.0 has about 5 or 6 game changing things of this level. It's kind of unprecedented, honestly, and that makes it really hard for me to know how to approach it and talk about it. So we have to continue. Why my streams are long. I'm sorry. I'm trying to keep this short. Okay, maybe 5 or 6 is exaggerating. Maybe like 3 or 4. There is an LMM text on the Solid V2 docs right now that are at least temporarily right here. V2 docs for the RC. There should be an LMM text in this one. Yes, and we're going to get to this in 2 seconds because it's important that refetch has its own semantics because it has a different meaning. And that's what I'm saying. We're barely scratching the surface here. I could probably do like a front-end master's course, like just solely on async reactivity in Solid. The unexpected part is that the blood of the framework is that you treat async data like normally. You just intuitively expect how it works. Yeah. Yeah. Well, or you can get it for free right now if you continue staying on stream with me. This is just the rough version. I'm gonna have to practice it like a dozen more times before I can do the front end masters version. So, okay, reads are great. What about writes? Because the refresh question only matters if you have writes, and or there's one more read thing I want to do. I'm very, very, very sorry. I just have to show this one off. This is the demo I give people to prove that they have transitions in their app, and I think it's still an important demo. Is pending is a transition-based affordance. It's not just about downstream of async. Obviously, if you ask async if it's pending, it's freaking pending. But there's a difference with React is that their use transition has a pending. So how do you know that you're transitioning? You could look at the data, but what if the data is not on the page that you're showing right now? What if you're moving from page 1 to page 2? How do you know that you're pending? Well, part of it is, another mechanism I can show you in a minute around actions, but I don't want to, or optimistic state, I don't want to go there right away because that's very process-based. It's very like effect or action thing. And right now we're just talking about reads. We're talking about navigation. Navigation should be pure. So what can we do here? And the answer is actually pretty simple. Because we know the graph, we know the change that triggered the transition. We can trace it all along. So we don't need to know the async data that's on the other page, the lazy component. We don't need to know that. We just need to know if the thing that you wrote to initiate the transition is pending. And this is where we're like very much like React, even though they don't have this API, and where I think Svelte, it's a little bit more global, kind of falls off the cliff a little bit. I mean, it's fine. Pending global works in this case specifically, but this nuance is beautiful. We just ask the tab, which is a normal signal, if it's pending. Side note, new class syntax. We have CLSX at home. Full credit to where it belongs. I saw Svelte do this, and I was like, "Why?" We had we had this in game. We had class lists that was kind of like this, and then Svelte brought it into the native class, and then now I'm like, I saw it Svelte, and I was like, "Okay, let's bring it into our native class." I was worried too much about performance. This is technically a performance deopt at the most micro level because now the class binding has to be smarter and has a fork in its logic, and it requires pulling in more code. This is an example of where like ergonomics beat like the micro benchmarkers. It's just so much freaking nicer to be able to just go class tab and then go pending is pending. But that's it. We set the tab, even though this is a switch matched in solid, conditional. This child is, let's look at what child does. Child has an async memo in it where it some randomly takes some time to fetch its data. And then child with loading has a scoped, has its async memo, but it scopes it within its own loading boundary. So this lets us show both forms of our navigation, because we can ask, initially when we load the page, we see our loading boundary like we expect. It's right here, and it's using this loader thing. The only other loading boundary is on tab 3 right now, which also has a message to it that says specifically loading 3 or tri. So how does this example work? When I click onto tab 2, oh, that was too fast. If it's slower, yeah, we're gonna slow this down so we can see it. I'm gonna give it a floor ceiling of like 380 or something. Let's try this again. There we go. Kind of turns gray from that pending indicator. I have a delay on the CSS, so it doesn't turn gray right away, so it's not too jarring. It only does it after about 200 milliseconds. But as we click between these, it knows to switch pending, even though the thing that's actually pending is downstream from that change on a separate off-screen tab. And more so, see how this counter keeps on counting? It's technically being rendered separately on each page. It's not like threaded through, it's just the props out count. But what it means is when this page unloads, like think about it, when you navigate to a new tab, what happens? You set tab to new tab. It ripples through the reactive system, right? It ripples through your rendering system. And now this switch switches to this switch. It literally unmounts, removes it, should free up and clean up everything that's underneath it. But our problem is because it's async, we don't want it, we're still showing it on the screen. We don't want, this is the transition or held behavior that we want. But at the same time, each page, there's a signal triggering here that getting passed through it. So each page is live updating while this is happening. You don't want the second you click on the tab, the whole page to go dead. Like, yes, in a lot of cases, you don't want people interacting with it more. That's part of the pending affordance. You might want to disable some buttons on it or whatever. But you also, let's say you're doing some kind of animation, or I don't know, you're doing some kind of thing that you're triggering through. It shouldn't stop counting even though technically you're already on the separate page and thing. This is the transition behavior. And in Solid 2.0, it's implicit, again, because you can just set the tab and ask if the tab is pending, and the rest falls out of it. And if you have a lower loading boundary, well, the navigation becomes instant. See, we went instantly to the page. We can see this right away. It's the lower loading boundary that caught it. This is no longer pending, right? The async itself, if it's pending, will stay pending, but something upstream of the async, once it's allowed to show the value it's supposed to show, it's no longer pending. Pending is the gap between it being able to show what it's allowed to show. And when you have a loading boundary masking the downstream async, it's allowed to show what it can show. It can go, it doesn't have to worry about tearing. The reason that we hold the values is simply because we don't want the UI to like show up here while still showing the content for DOS. That's why we hold it. We don't want the tab to immediately go across. Unless we want to, unless that's the affordance you want. But in our case, this is not the affordance we're going for. We're going for the more like mobile app, kind of smooth animation type performance where the whole thing moves together in sweep. If you wanted that experience, well, you can do it by nesting a loading, like I'm showing here. But generally speaking, we're holding and doing the less jarring, keep on showing loading spinners on navigation. Some people consider this less jarring. Actually, it's not some people. Studies have proven that this kind of approach is less jarring than like always like having loading spinners, you know, coming in at you. You go navigate, 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 content, rip, 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 rip. It's the same problem, a similar problem to like the suspense ripping. But obviously sometimes you want to show some stuff and not other stuff. So nested loading has its value. But the same system without having a transition wrapper actually gives you the same power. You just have to ask the right question. I believe so. I don't know what you're doing, but I think so. I don't know if we have tests for that, but the front half is just a computation. It runs at the same time as all the other computations. We yeah, it is crazy stuff. I don't think I can talk about it on stream though. I'm gonna steal 2.0's thunder, and I don't want to do that. Um, but yeah, like, okay, I think I've finally done the read part of the equation. You kind of you can start seeing this full picture kind of formulate here, where you have complete control over your affordances, and the graph does the right thing. You choose where the pending is. You choose where the loading is. This is a design aspect, and the framework just knows how to handle transitions or held consistent UI by default. Okay. Let's go back to our more realistic baseline number. Okay. Because like it's funny, I'm like making these really big artificial delays so you can see it over the stream, but like in a real app, what this means is sometimes it's an old demo. Sometimes when stuff is slow, you'll see that pending, but other times when it's fast, you won't even notice. That's why people, sorry, that was the wrong one, going between these two. That's why people do this kind of affordance, is that the idea is the majority of the time, if the response is under 200 milliseconds, the end user doesn't even really pick up or a clue on the fact that there was any kind of affordance. It just looks like they just went to the next page. When it's slow, like this happens, you're like, okay, I should tell them because they need to know they clicked the button. But otherwise, you know, it can be fast. Although now I'm getting all slow ones. Like what if our response on average was actually 80 milliseconds plus a 220 thing? Let's do that. What if it was like that? So that was a slower one. We got a little bit of one, but these are relatively fast. That was a slower one. Fast. Like this is more like what a real app would see. Like this is the kind of thing you think about when, just so that when there's that rare occurrence that like something really bad happens and things go slow, you know. Anyway. But in order to do this, you need the tools to do it. So it doesn't mean don't ship this. It just means have the flexibility to scale. All right. Let's see, understand features. Maybe you can explain these features. Yeah, I mean, is that our audience? I mean, might be. I don't know. Prefetch is a thing. Yeah, sure. Prefetch is a thing, and these all work in concert. I love prefetch, but you know, and caching is a thing as well. But at your core mechanics, you want to be able to do the most because there's always the cold case. I think I do think a lot of solutions basically said, oh, well, with prefetch it's good enough. I honestly think that's how sometimes Next.js uses away server waterfalls and stuff, you know, and like not using like route loaders or preload. I have always been big on structurally creating your app in the way that will lead to the most baseline performance, and consider stuff like preloading and prefetching a last stage optimization right before getting to compilers. right? You want your stuff to be fast by architecture. Like that's the thing. Like you have to look at the fundamentals first, and then kind of go from there, right? Like a perfect example of a fundamental. If you click something and it goes to the server, and you wait until it comes back from the server to show anything to the user, it's going to appear to be slower than if you give them affordance immediately before going to the server. There's just no way to get around that fact. If one side you're measuring the gap from like click to show, which is instant, like however long it takes, like a animation frame, and the other side there's no way for a network to be as fast as an animation frame. It's just physics. It's just the core baseline truth. It doesn't mean we shouldn't optimize the network path. It just means that we need to consider, when looking at the full spectrum of solutions, how client-side affordances fit into the puzzle. Right? Like there's no changing that fact, right? And I think everyone understands that there's no changing that fact. Okay, so that's read. What about write? Ever made to do MVC? Yeah, I think we've all done it. This this is a great thing. I made a very basic one. It doesn't have all the functionality. This one literally has 3 functions. You can go add a to do, check a to do off, completed, and delete them. There's no filtering. There's none of the other advanced stuff. I have an example of all the advanced stuff inside the solid repo, but don't worry about it. Right now, this is really simple. There's 3 things we do. On input, we add a to do, right? And then down here inside our each to do, we have on toggle and on remove, which just, again, I love that new class syntax. We just kind of wire it through to do completed and whatnot. This is a very simple to do app. This is like to do MVC that the solid, like if you go into the official repo for 1.0, this is the same thing. What I did was I abstracted it. If you ever go into to do MVC, people like try and make it, the reason it's called MVC was because it's model view controller originally, right? So people were always trying to show, like, it's so funny because when front end came out and people were first making these demos, it was not very structured. Sorry, it was jQuery and all the spaghetti imperative code. Sorry. So the whole point of to do MVC was to show that you could do structured, real programming in the front end for an application, even though this is like the most trivial application ever. So some of the earliest to do MVC examples are the most convoluted things you have ever seen. And it's funny now with modern JavaScript, if you go in and make like a 2 MVC with just vanilla, it's actually really simple and really clean and it looks great. I think the creator of Front End Masters actually went and did that. And but getting back to this declarative root, what it means is usually there's the model and the view and the controller. Well, we don't really have a controller here. We're more MVVM or whatever. So our view and our view model are kind of like the same thing here. Well, we basically have components and models. So I extracted the model. So the model is here to do, right? And I also made a fake server. You could pretend these are server functions or whatever API endpoints. I don't care. But the gist of it here is that I have an app that I built that has some basic functionality and it just kind of works. And then inside, this is where all the work happens. So because I'm a client-side app, I have a store. And if anyone's seen stores in Solid, they're like granular signals. Each individual operation pushes separately. We don't have to re-render anything. If you update the one to do, it's a signal straight to the to do to the list. We don't have to rerun the whole, like to the item in the list. We don't have to rerun the whole list. We don't need like a memoizing compiler. If you understand that each property is its own separate signal created lazily, then it becomes really easy to understand that when we update a to do, we don't need to, like, it's not immutable. We don't need to rerun the list. We don't need to rerun all the components in the list. We don't need to have a key on here for memoization as reference because we're not recreating new DOM nodes. We're literally just going in and being like, okay, to do completed. Where is that? Oh yeah, props to do completed. Yeah, let's trigger that thing. Or obviously deletion or addition is going to affect the list, but our list is optimal, so we only actually rerun the component for the new ones that are created. This is just base solid 1.0 solid mechanics. So what's the API for stores? Before we had a very immutable JS thing, Falcor, I was very inspired by like those APIs. Solid 2.0, I just caved. I'm like, screw this. I didn't want to go MobX full mutable. As I mentioned, the ability to write is very, very important. You shouldn't just pass proxies around that can be just written anywhere. It's a terrible, terrible, dangerous pattern because you lose that contract. It's the classic immutable contract where you like call a function and pass some complex data in. What's that data on the next line of code? You don't know because you didn't create a contract around the rights. And like earlier when we were talking about create memo, and this is important when you consider like the server the source. You need to be able to constrain it. But here, this is not a server. This is your everyday to-do MVC. So all I'm doing here is literally pushing a to-do on, filtering out a to-do, and then finding the to-do in the list and marking it as complete. This is the one right there. These are list operations. Done. It's pretty easy. So my question to you is, how do we make this async? To do demos under I don't know what PHP demos. My memory of the early 2000s was that we did all of these really long round trips. I mean, to be fair, I did a bit of PHP work. I was mostly stuck in ASP.NET and ASP web forms. And I don't remember anything about that era being even remotely good. It was the worst garbage that I call it the dark ages. Like part of it, basically, it was like a time where we tried to pretend that client interactivity didn't exist, and like it was such a big lie that like it was really awkward. Like I remember like we used to have something in ASP called like view state, and we just like render the page and serialize like all the data that we needed in the client across the wire, and then the client would edit it and then serialize it all back again. And then they're like, okay, well, let's make this more efficient. Let's make partials. Let's like where we just swap part of the view, and then we'll make the lifecycle on the client on the server smarter, so it doesn't run the full lifecycle, and it just runs like the parts we need to do like a in place update. And it kind of worked, but then like literally like this is like a misplaced kind of situation, like because there's a lot of situations where that did work. I made CRUD apps, like admin, like very simple like admin CRUD apps that was fine for. But like I was working in social media and we had a Rails backend, and then we switched to JavaScript and just did the logic in the client, and it was like the app was like 100 times faster. Like it was just all the machinery went away, and it was just like so clear. Now, obviously, we weren't measuring the load times of that app for like the initial load for the JavaScript and stuff, and our app wasn't that big. But like the simplicity that came from just simply having the data source in one place, like being able to mutate and like give all the affordances that we need, like we're doing drag and drop of photos and we're tagging and we're doing all these like kind of interactive things. It made update panels look like a joke. I still maintain. Now, don't get me wrong, technology on that side has improved drastically. And things like HTMX keeping really close to the core web level contract is really nice because it lets us rebuild on it in a fresher way. But I'm not like necessarily discounting the whole approach fundamentally. It's just like the things as they were implemented 20, 30, 25 years ago or whatever, were kind of terrible, like really terrible. And you can't blame it. It was 25 years ago. But yeah, at least that's from my perspective. Like, like, like I'm coming from a time period. I remember like going to travel agency sites and like having those cascading drop downs of like, and you could say this was bad, like developers just being dumb, and I agree on that. But I remember like switching the country to load the city, like, and these cascading drop downs, which would cause, yes, partial updates, but you'd be like freaking waiting there. And yeah, the solution is do some preloading and like predictive stuff. It was just every interaction felt like you're submitting a whole form, and like it just you could go like grab your coffee and come back. That was my memory of the web in 2000. And as I said, probably not doing great things, but that was like that's like the equivalent of dumb React developer today. You know, like where people like it's like the baseline. Anyway, sorry, I got way off on a tangent. So, okay, cement this into your memory. You see our three actions here, and now you got this in your head. And you see our app. It's pretty straightforward. It's a for loop over some to-dos. We pass some actions through. We do our actions. We click destroy. Now, I want to show you another app. I don't think I changed anything in this one. Sorry, I clicked on the. I almost made the bad reveal there. Okay, now if you look at this app, it looks almost identical to the other app. Oh, there's a loading. I cheated. What's this going on here? Oh, right. I haven't updated this one with the latest 2.0. Okay, that's fine. That one that should have happened. Okay. Okay. 4 went back to being keyed 4 went back to being a direct pass instead of an accessor. Better for performance and more literal to what's actually happening. Okay. There's a loading. I added a loading thing here, but we can delete this as we've already proven before. If we really want to, we can remove this. What I'm showing you here is the exact same app. It should look like the exact same app, except I made it async this time. You may be like, what? See, I removed the loading, and it still works. I'm going to leave the loading here just because, let's face it, you don't want that wait time while you wait for the to-dos to come in. You know, okay, there are none. That's why it's blank here. But we can ignore that loading indicator for the most part. This app is identical to the one I just showed you. So I told you that this was async, and the thing is, you can see now because add to dos is a promise void, remove to dos is a promise void, and more importantly, I guess you can't really see it. Yeah, you can't really see it through the types. Okay, I'm going to tell you it's async, but I want you to watch this. Nothing you see here looks differently than what I just showed you before. What version of this is this on? I feel like we need to bump this up a little bit. I'll worry about it later. Okay. Right. So what is async about this? Well, let's go to API TS, because there was no API TS in the other one, or it wasn't doing anything. There is a delay on these to-dos. You can see it. There's 400 milliseconds on saving the to-dos, and if I go to get to-dos, there is also a 400 millisecond delay. So technically speaking, between every click and save here, there should be 400 milliseconds, but stuff is happening immediately. Right? So what did I do? There is this delay, and the app hasn't changed. What did we do? Well, let's look at our new to-dos. First of all, It's no longer store, it's create optimistic store. What's create optimistic store? It's a store that's saying that my rights are not the authoritative truth. The server is the authoritative truth, but my rights are what I think the future will be. That's what optimism is. It's basically saying, while this thing is happening, this is what I think it'll be. Because if you didn't have optimism, because we do consistency, you wouldn't see the update right away, right? You would add a to-do and then you wait for it, maybe show an is pending or something to give an indicator, but then the to-do would come back when it did. Whereas an optimistic store is saying, hey, I think this is going to be the truth, but I don't know yet. And then we need something else for this, because we need a way of tying our change to the eventual update. We need to make sure that it all happens together transactionally. We need to make sure that if we have multiple things in flight, they're not stomping on each other, they're not canceling each other out, there's no race conditions. We need a way of saying look, if these things entangle, we can't accept the truth until we have the complete authoritative truth from the server, right? We can predict as much as we want, but we shouldn't get ahead of ourselves. You know what I mean? In the sense of we can't say this is true until the server verifies it. And if there's partial states coming back at the same time that could impact each other, we shouldn't consider it committed until we have the full story. So we needed a way to extend the transition, because yes, transition, sync frame, anything that happens as part of that transition, all those rights. But the problem is when you have a mutation, there's no graph connection. You don't know that what add to do does. It's something on the server, and you can't connect the dots. You don't know when it comes back, you're part of the same operation. We needed a wrapper. And the problem is there's no such thing as async context in JavaScript. So if we made these async functions, you have this terrible, terrible problem that when you come back, there's no connectivity. There's no way for us to say, yeah, this is the same thing. You have to call, if you React, call start transition again, which is crazy. And in our case, because React kind of has one global transition, we were doing granular parallel transitions. We actually had to thread the transition through the arguments, which is terrible, because when you create an action or something you want to use, you just want to have the argument, these signatures, other than the void promise part, which is useful for hooking into external stuff, is the same for these. This takes a to-do, this takes an ID, this takes an ID and a completed thing. We don't want to change what our actions are doing. I did not touch this file at all if you skip that loading indicator. All I did was wire this to a backend. So API get to-dos now is where our store derives from. And a derived store, this not just optimistic store, but generally, when you return something from the store API, store APIs are designed for mutation, but when you have a derived store and you return something, it automatically does a reconcile diff in the background. In this case, the default is ID, but you can change that via configuration. So we're basically doing a diff of, and the reason why optimistic is important is because we're not just diffing the server state versus the previous server state. We're diffing the server state versus our optimistic prediction, which means that any nodes or things that we create during our optimistic phase, even though they are never the source of truth, they can be reused. So if we optimistically create a to-do, it's not just a second list, like the old remix optimistic approach. It's actually, it's more like GraphQL, except there's no rollback. If you've ever used GraphQL stuff, you always had to write the forward motion and the rollback. We're handling the rollback automatically. If stuff goes wrong or it doesn't commit, well, the server becomes that authenticated source of truth, and it corrects the diff. So what we have here is we get our to-dos, and then we have an action. Now, the action here is yielding our actual server save, and then it's calling refresh. Someone earlier asked, how can you do it without triggering? And the answer is we have a refresh API specifically, which is invalidate me and let me try again. And if I change, I will notify everything downstream that changed. The default thinking of refresh is that it doesn't change. This isn't necessarily a direct pending thing, and it happens too late anyways. What I mean is if you need some kind of optimistic state, some kind of indicator, it needs to happen before you do the save, not after it comes back from the server. That's already too late. So refresh is not really designed for that. It's just saying like, hey, let's go trigger the invalidate, like from a tan stack perspective. But what is the optimistic state? Well, remember our old example where I told you to burn into your brain what the mutations were? Well, we actually just kept them because it's still a store. Our predictions of what the to-do app will be are exactly the same as what our mutations were in the original sync app. We just push a to-do when we add a to-do. We filter it, or we mark it as completed. Then we go to the server and do the operation, and then we refresh the to-dos and get the latest and compare our optimistic state against our real state. If nothing changed, we do no additional work, right? What's beautiful about this is a fine-grained change. This is classic solid. You're just changing the one field that updated in the client. And then when it comes back and does the diff, if nothing has changed, we do no work. It collapses the whole mutation cycle into fine-grained updates again. This wire format might not be the most efficient, but we actually have a bit more of an answer about that as well, which I'll get to in a minute. But from a strictly client-side standpoint, and this is built into the framework, just like optimism. This is not a solid start feature. This is solid. This is core, because this is part of the signals library. This is what I was trying to get at. These are fundamental pieces that you need in order to build on top of this stuff, right? This is why the signals library is so large. And the end result is that we were able to completely move the source of truth from the client to the server without touching the UI and giving the exact same experience to the end user. Yeah, some people dislike options. Maybe you should cover this in just about guessing the future. It's about showing something while waiting, whoever you choose. Yeah, exactly. And actually, my next example will show that. It doesn't have to be a prediction. Predictions are useful when you're mostly right. So like when you're doing like a Trello board or a Trello board or like a to-do MVC, something like this, your predictions are mostly right. So it's okay. And if you're not right, the server being the authoritative source of truth. Like if you look at this, there's actually no way for the client to diverge. Like this set to-dos being an optimistic store can't lie, because the optimism goes away with the transition. The server always has to be the source of truth. This write, if there's no async, this write does nothing. It's a no-op. Like basically these run in separate lanes. There's no divergence here. This is only a best effort thing in terms of trying to like get ahead of it. But yes, it doesn't only have to be a prediction. But I think it's important to understand that by the shape of the API, we're basically saying like the server's the truth here, and we can't actually diverge from it. There's like every write is tied to the transition lifecycle and is reverted if not substantiated. So there is no like client drift from server happening here. This is just structurally by design. This is what the good design looks like. Okay. And what Gabriel's getting from is the next version, which is, yeah, you guys couldn't even tell that this was a to-do app, right? Like that it was async. The optimism mirrored the client identical because the UI was different. So in a real app, you actually need affordances, right? You need to go, what happens if it errors? Like this is all good if everything's good, but what happens if it errors? And the answer to that is, well, what happens to your app when it errors? Well, the code's still mostly the same, but now you actually need affordances, right? You would need to add those anyways. So I added one more action, retry, okay? And what else did I do here? Let's look at our to-do. I did some funny color thing. The version in Solid's repo is better, But essentially what I'm saying is like, if it's errored, we're going to make it red. If it's pending, it's turquoise. And I'm actually using the optimistic state here to extend our schema to include pending and error, because these can be layered on top. And this is a very kind of clever thing, but I think it's a microcosm of the whole front end ecosystem. There's server authoritative truth. There's client ephemeral state that lasts for the session or the life that you're inside of it. And then there's in-flight transition pending state that only lasts the lifetime of whatever that action is. So we have three representations. The best way to make them all link together is to derive them. And I just pushed it into the schema itself. So basically, if there's an error, we'll show a retry button. Like there's more logic now inside the to-do because we need to handle it, but there would always be more logic. If the optimism, or if your experience, mirrors exactly what the client's experience without async would be, you have no extra work. Your extra work always comes from the gap between the affordances that come with, like at a baseline, if you're fully optimistic, then you could just, like in my last example, you could set that client delay to 5 seconds and you're not going to notice any difference. Like the network could go as slow as possible and you're basically just doing the same thing. The difference comes in when you actually go, hey, when this is pending, I want to show it differently, or when this is errored, I want to change this. When you actually have affordances to actually take into, but that's additive. That's not the baseline, right? That's something that you go, okay, I built this and it's smooth, but then it's like, I need to give people more affordances. And that's work that we didn't add to you, like give to you. You would have always had to do it. So yeah, what this means is I have this thing failing now 30% of the time. So when I say, hey, see, you can see it's green when it's being added and we have a couple. And when you notice when there's a couple going, they actually stay highlighted until they both come in because they get entangled. There is this entanglement thing. But see, this one failed and now there's an add to do, retry. So when we try it, okay, it's good. And it comes in. And you notice it didn't reorder when it came in. That's because the client in this example is responsible for the IDs. It's just kind of, so it actually kept them in place. This is like, if you had something Strello where you basically have to give it like a client UID if you want to like keep identity across it. That's not necessary in all optimistic cases, but it fits well into this. So we got some errors, and this is not the best UX for errors because my guess is if any of those it's going to pop back in. You could make it not disappear when it errors right away and show it in a different state. You can use different affordances. My affordance for this is actually literally just undo the error or like undo the hiding and show it. But that's on me. Oh, this one failed again. Okay. That's a me design fail, not the system fail. So what does to-dos look like in our example? Well, I took our server to-do and I extended its schema interface by giving it a pending and error. And then what else did I do in this example? This is a little bit more complicated now, but with our actions here, add kind of does an ID lookup. But I think the actual most important part here is looking at what I did with the optimistic store. It gets its value from the server, and then it layers the errors on top because these errors aren't lifecycle the transition. They're the client state. So we have server authoritative source, client state applied on top. This is your baseline. And then as you go, apply optimistic updates, which most of them are actually identical as before. The only difference is on the add. To get that cool thing where it didn't move, what we did is we actually do look and see if there's already an existing to-do so we can match it up on ID. But the key thing is on all these operations, we mark the to-do as pending true. See, that's the difference. When we toggle them, I'm setting pending true, and then when we do our action, we basically, if there's an error, we write to our errors with the information we need for the retry, and then our errors will then layer on to our thing, and the whole thing just flows. And yeah, I mean, this is more code. In the end, with all the affordances and all the types and everything, our example now is like, I don't know, 170 lines of code. But here's the challenge. I doubt you can do this in any other framework in reasonable where we're not like trying to like trim the white spaces or doing that in less than 240 lines of code. I think we win by like 60 to 70 lines, just because of the simplicity of the structure. You know, client state driven ephemeral projections is how I think about it. It's the right way to think about it. Right. I just wanted to show like this kind of completes the right story, because I know people are like, what the hell are generators? But async functions with trying to resume them is not good. All the way you should view a generator for our actions is simply yield a promise instead of a wait. It's yield instead of a wait, and then it basically works the same way. You can even get the result from it and stuff. Just yield instead of a wait, and it just means that we can continue and keep all the pieces together. That's the key. It's that we connect the refresh to your original set. It's all one transaction, and that means we can entangle it and we can make sure that we can provide completely consistent UI while the optimistic states are running. This is all part of completing the puzzle. Okay, I don't know if this one is explained as well. This doesn't feel as big, I guess, for people, the way I explain it, as the first like read side does, but this is actually huge. Right? Like the implications of this at a systematic level means that you can actually build as a baseline like very consistent UIs without much wiring. You just the be fair, the action thing is like React's transition, you know, the core differences, because we have those ambient transitions and they combine with the actions where you call it, you don't have to bury the actions in your reusable components. This is the biggest difference in the thing. You don't have to go make your component library suddenly be click action. You if you have a button that has an affordance, it can go in there. Do I have an example for that? I have an example for that. You I don't know if I have an official example for that. Mm, this is close. This isn't using Optic Store. It's just using a projection. It's like kind of doing it manually. But what I think is important about this example is you can kind of see it is you could have a button somewhere deep in here create its own optimistic state, set it inside its own component, right? Basically go, oh yeah, I want to track my own optimistic state. So like this is just saying basically yeah, here's the remove one actually. Set it to true. So while this is, it starts as false, so it's always false. And then while this action is happening, set the true. There's no actual action here. Like this is just like, it could be, this optimist state could be like, is my button doing work for all, you know, and it could start as false. And then whenever someone clicks it, you can say true. And now if there's sync stuff on the other end, no one ever sees the true, it just does it. But if there's async on the other end, you know, hooks into someone else's action or something, then your loading affordance happens automatically. So you can design, it's kind of like is pending. It's the opposite side. Is pending is like, are my sources something that I need to wait on? And then you can use optimistic, like just a simple optimistic state triggered in not the full store. As I was saying, like, hey, do I need an affordance for some kind of process that I'm triggering? And because it composes this way, there's no start transition down here. What actually happens is we register our optimistic state change. We call props on remove, ends up calling remove to do, and we go into remove to do, and we see remove to is an action, and it just wires it up, and they go, okay, well, the life cycle of that optimistic update is now tied to both it saving the change and to it refreshing the data. So these things compose really nicely without you rewriting all your component libraries. So what I'm getting at is like it composes on reads and composes on writes in this wonderful way that gives component authors complete control over their own affordances that they want, and yet at the same time lets you as the application developer be able to define very clearly in your scope what you need to happen. Okay. It doesn't need to be, is what I'm saying. The optimistic update does not need to be in the action because there's ambient transitions. Whenever you're in a scope where you can write, it starts a transition, and calling an action called in that transition gets just piggybacks on that transition. So you can literally you can use optimistic without actions. The reason you need actions is you have some kind of change, like a mutation outside of the graph. Like you don't know what safe to do impact. You might know, and there's an API specifically to call it out called effects, which I'm not talking about right now. It's kind of more advanced API, but the graph doesn't know what some side effect, some mutation is going to do. So for that reason, that's why we have action, so we can tie the cause to the effect, you know, like so to speak, like make sure that we know the mutation is tied to the refresh. That refresh doesn't have to be refresh. It could have been like get the result back from that save and add it to some, you know, like add it to some source and then go. Like maybe you aren't using an optimistic store, or maybe the optimistic store derives from an actual store. Like you can layer it like that, and then you can actually update the authoritative source granularly instead of doing a full refresh from the server, right? There's simplicity in doing the full refresh like I'm showing here, but you could also take the result from the action and use that and save it, and that would also be fine. But the key is you have to understand is that these things, both the save and the graph update, are related and related over async, which means why we need the action wrapper. I hope that makes sense. Um, so that's number two. Not there yet. We're not talking about server components. I can show you a very quick like poor man's island example for 2 seconds, but I really don't want to get off topic too far. Um, I made I made this example the other day just to I made it on stream, but I kind of improved it since then. I wanted to show that I just made a very simple app, um, just using like straight beat plugin, where I from the server I basically hijacked it. Like you don't need any of this wiring anymore because we have start mode, which I'll talk about as piece number 4, 3, 4. But what this example does is it renders to stream, which renders our whole app, which has HTML and all our stuff from head, has our hydration script, all this stuff. But actually, I don't even know do we need the hydration script. Yeah, we probably do because the islands hydrate. And then, but it wrapped it in a no hydration, which means that the main part of the app doesn't hydrate. And then I made these counter components that have a prop passed to them. And then what I did was I import these as island components. Now you might be like, okay, this seems like I'm showing a framework feature. No, I actually literally just wrote this from scratch in 2 seconds because we had all we needed. Like, how did I make an island? I used our lazy function to grab the component and then had it return a component that increments. It grab lazy components in Solid have a module URL, so we know where what the bundle is. This is something I added earlier on because I was kind of like trying to think of how the asset management works. If you actually notice on server, we pass the manifest in. This is important for streaming and asset preload. Solid handles that all automatically now. But what it means is in our really dumb example here that I created, we can make a fake web component or element. We can pass in some arbitrary ID for our client placement. We can pass in that URL and stringify the props. And when we render this on the server, we'll just output a hydratable version of the component with those props passed in, wrapped in this native element. And then the entry client, which I haven't shown till now, instead of having one hydrate call, it does a query selector on all those native elements. It grabs the URL from them, lazy imports them because it's the same URL that we identified from the server, takes the props that we serialized with JSON serial. Honestly, you'd want to use, like, if you're doing this real, you use like Cerevel or something real. But I just JSON parse the props coming in, and then called hydrate on the component that I grabbed from the lazy here, passing the props in, and then using that ID that we passed in, we match up the render ID, which is its scoped thing. This is like how we do it in Astro, so that each island has its own scope, but it's still part of the same tree. It just means that the resources don't clash. And the end result is we render something on the server and we have hydratable islands, but this actually is, these are actually island buttons, just manually wired. Solid has no islands feature. I literally just wrote it from scratch by using document query selector and then making a small wrapper around lazy. These aren't actual web components. I just I like, do you want me to like make this like a div and with a special attribute on it, like data something, just to, and put like data things in front of these just to spite you guys? The Astro integration I got to work on, but generally the same mechanics are here. I realized partway through doing Solid that literally making islands is super trivial. Like I'm not suggesting people go out and make an islands framework. But as a proof of concept, this is literally like less than 100 lines of code. Like, it's, there you go, islands. Okay, back to the actual, what I actually want to talk about. You know what, whatever, I'll share this so people can think what they want about it. Okay. So now I'm gonna look at, I play with actually one of our actual like up-to-date templates. That one actually had a semi like older template. Okay, so what we got? We got, should I use the SSR template? Yeah, I'll use the SSR template. This one, 0.3 ties it into 0.4, and I haven't really decided how I want to break it out about much, but essentially home about, this is a very simple app where, with terrible style that AI generated, where there's two tabs, there's no router or anything. This is literally just, you know what? Let's pop this in here. How does, speaking of master, how does Solid 2? Yeah, I think we're still well below, yeah, sorry, we got bigger, but like, because of how tree shakeable, we're still smaller than Vue and Svelte. We're not smaller than Preact. That's where my gripe is. I'm always like, oh man, Preact like plus signals still comes in around like 5-ish kilobytes for like the dumb, simple, like I'm just doing a signal like little island thing, where Solid now is like 10 kilobytes. But Vue, what Svelte in that case is like 14 kilobytes, and Vue is like 23 kilobytes. So yeah, yeah. It was with Solid 1, but not with Solid 2. You need to, yeah, you might need to catch up a little further back on the stream. Solid 2 is larger. Yeah, 4 kilobytes is about the right core size when you don't have to worry about hard problems. But back to this example. Oh, sorry, I didn't highlight this. Hey, Dom. Thank you. You guys know Dominic Ganaway, creator of Inferno. Yeah, core team, creator of Ripple, and most recently Octane. I don't think in this chat are being answered, only YouTube. It's possible that people on YouTube are just asking better questions. I actually, you know what? Let me open up Twitch. I only see like a couple questions on Twitch. So maybe there is a gap here. Maybe not all of them are getting through. Maybe people are sharing stuff like URLs. It doesn't make its way through to me. Let me quickly open up Twitch to make sure I'm not missing anything. Yeah, I'm on Twitch right now, and I don't see very much. Anyway, this I'm just using like a switch component and buttons. Like AI generated this one. I'm sorry. I just needed a template to kind of show like when it's one way it's home, the other way it's about. No router. Just this demo is actually mostly a show off start mode, but what I wanted to what it comes into what I want to talk about is the third kind of piece of the async story, which is use server, because you guys are asking for what's Git to dos or Git whatever, and I've been writing all our demos purposely looking like this, right? Create memo, get something, right? We've seen this throughout all the demo code that I've showed today. And the reason is, right, in a lot of these demos, they were just client side. So what does it take to move it to the server? Use server. And yeah, I guess this really has to tie into the Vite thing. Yeah, maybe this is actually only the third point. So yeah, maybe we only have 4 headlines. Yeah, maybe it's only 3 headlines. Um, have to think about that. But because this one's a little bit thin. The point, I mean, this one's a big one though. If I combine it all, the big takeaway here is signals were super powerful, and we own that. Server functions were also super powerful, and we kind of let it be like a solid start thing. We should have launched it as it should have been a solid thing. We just weren't in the position of it. But I feel like we came up with a really powerful thing. You know, originally server $sign. I got to give credit again. This is an example where after releasing something, a year later, adopting React's convention instead because realizing that they are, I think this is sometimes where my gap is like for the actual like syntactual things, like Svelte is amazing at reducing the syntax, like in terms of like how much you write, and React is great at choosing the correct division from first principles in terms of like the tuples for the signals that some people gave us a hard time like why do you do that, why don't you just use one function, why don't you use proxy and all that. React is right completely from the contract standpoint if you want to keep things structured. And similarly, use server is right. Server $sign was not right. And I know Tanner disagrees and I know other people, but this to me, this is just fundamentals. This is not really a disagreeable fact. You want to, these aren't composable, and you want to mark the function in its current location. Like you shouldn't fool people to think that you can make wrappers or you can you can wrap a server function and that code is on the client. You can't compose the server behavior itself except for within it. This is why we don't ship like validators and stuff. If you want validation, if you wrap it with a validator, well, guess what? Now it's on the client. If you put the validator inside, that's probably where it should go anyways, and now it's on the server. The problem with trying to combine the APIs is something that Theo, T3GG, whatever, pointed out to me. I came on a stream a few years ago, and I was showing all these server $sign functions, right? This is like 2022, like 4 months after we released server functions. And I showed him the API, and he was like, okay, so which of these functions is being called on the server and which ones are not? Because we were passing like a couple of places where we had like some callbacks, like on success or whatever, and doing this. Like it was basically like TanStack query on some of the APIs. And I was like, oh, we have a convention where it's generally just the first function. And like he just, it really bugged him. He couldn't get over the fact that when he was looking at it, he was like, I need to think about where my code is running. This is before React revealed use server or anything. Like it was way before. And it stuck with me. Like it was really good impression because I was like, you're right. And then we started seeing the ecosystem. We started seeing people come up with like wrapper, like PRPC $ and all this kind of stuff, like their own compiler. Like they had to write a compiler to get the like the API they wanted. And I was like, why are we fooling people? The directive thing is the most honest approach. It doesn't play nice with TypeScript, which is why I understand people have different incentives. But I have to be, my master is the physics, not the ergonomics. I'm obviously going to try for the best ergonomics possible, but the physics is more important. Yeah. Well, the thing is, who's responsible for passing the headers? The Do you know how we pass headers? There's a few ways to do it, but um, let me think here. Like first of all, what if you want to use a get instead of a from solid JS? Sorry, why am I using the wrong backtick? Solid JS web. Yeah, okay. So if you want to make this a GET request instead of a POST request, we can wrap it because the client makes the decision, right? If you're similarly, we have with Meta, like where you can mark specific functions. We also have a middleware, so you can prepare server functions. So you can inject if you need to put like auth tokens on certain requests. You can basically mark them, like add some like admin route thing on your server function, and then the middleware on the client can basically apply those headers. Like there are ways to get to it. You just have to understand that those things are on the outside. So when I say get, the way get works is like this. Now it is a get. What version of Solid Web are we on? I thought it was in web. Is it in slash server functions? It's in server functions. Okay. I'm still getting used to the new package directions. Guess what? It's still streamed in after the shell. So now if we look in our browser, I don't know where is the network. Fetch. Hoping Stack Blitz will be able to see it. I don't know how Stack Blitz works on this. Why am I not? Oh, right. That was the original render. I need to go back to it. Yeah, sorry, my bad. Right, because on original SSR, we're not going to redo the request. This should be a get request, I think. Yes, it's a get request. Yeah, exactly. Sorry. Initial SSR, it's going to stream in. It's not going to make a separate request. So if I remove the get, actually, I always refresh just because like I'm always worried. Hit refresh. Good. No request. Go to about, come back. Now it is a post. So my point is there's ways to decorate on the client where it belongs, right? You don't need to hijack the, like, we keep the fixture, like there's no lying about the fixture position here. How would you serve different other magic syntax? It's not. It is definitely a compiled magic syntax. We need a protocol. The JSX is a magic syntax. The key part for magic syntaxes is having delineated boundaries, so you know where they start and end. right? JSX is really easy. You just look for this. JavaScript does not have this. This is not JavaScript. Guess what? This one's got an easy boundary too. Server $ is just a function. It doesn't have the same level of syntactical boundary. You could argue that this is just a directive, but I feel like there's more precedence. Do we need a query? Yeah, I mean, sure. Yeah, I'll push this out here. I mean, yeah, I mean, you can still use API routes. It's just, you could, a lot of the times, there's something nice about it fitting into the function. Like the reason I originally invented, or I mean, like, it's me and Nikhil, to be fair. I came up with a proxy version. He was the first person to come up with the compiled version. We invented server functions in the first place. Was because I wanted to find something that I could take my isomorphic client's single page app and just slide it right into the current thing. You start seeing how the full pieces all start coming together on the side, because the meat of this, of this third point I'm trying to make here, is that use server, just decorating a function, means that everything we just talked about, the graph, continues onwards. I showed you how we had that separate file where we kind of kept, like, this is a way of saying, like, look, this is the same synchronous code you would have always written, like we showed earlier. And now I showed you how adding async doesn't change your UI graph. And now I'm showing you that how moving something to the server doesn't change your AI, your graph, because it's just async. And since we understand async, like, do you start to see how this layers on? It's like we have a UI framework that's synchronous. We have UI that's synchronous. We make async almost invisible to it, except for chosen affordances. So everything just works. Now, the act of offloading stuff from the client to the server is also just one use server away. Yeah, this is just a Vite plugin, which goes to a point someone was asking about the OXC. Everything started rolling really fast for me when we were doing something, because I moved the JSX compiler to OXC, and then I was like, am I going to have separate OXC compilers? And then I was like talking to the agent, and they're like, no. So then we moved solid refresh transform. We moved the lazy manifest preloading mechanism that I built in a Vite plugin into OXC, and we moved server functions into OXC. So basically, the Rust compiler is all the compilers. We actually moved all the compilers, which is supposed to be part of my point number 4, which is the exciting point. But point 3 is establishing a layering. And the last piece of point 3 before we talk about point 4, I think headline 3, sorry. It also works function level, but you have to, or sorry, it also works file level. You have to consider, though, if it works file level, that your wrappers need to go outside. There's this like great example of the Svelte remote functions where they have use server or something like their equivalent server file. They don't have use server, and then they have the query and everything inside. And that always confused the hell out of me, because to me, the query is on the outside. So like when we use our router, and this is coming into what I'm calling the other part, point 3, about this composition part, is solid router has some query, query, which is like a very simple cache mechanism, like kind of like very basic deduping cache mechanism. And the reason for this is we believe that how should I put this? If we control use server, we control the communication protocol here for the server interactions. And I already found this problem with solid router. We actually needed to control the request. If you're a clerk, if you're some third party integration trying to do an image component for solid, if you're like Sentry, if you're any of these people, this is why 3 and 4 kind of end up collapsing into each other. Every meta framework for React requires a different solution. You have like Clerk Remix, Clerk TanStack, Clerk Next, maybe even Clerk React. I don't know what that one looks like, but you have all these different adapters. There's a headline here, which is the fourth one. The reason we collapsed it all in was because not just because of the efficiency of the compiler, but because there's one source of truth on communication protocols. Query, for example, lives outside in the router because that's an application choice. Caching and stuff is your choice. But the communication protocols, like signals, like server functions, even the web request to a certain degree, if you're handling server stuff, those protocols have to be established by us. We have obviously a way, if you integrate with H3 or Hono, you have the native event that you can access and all this stuff. So you can always like tie in on our protocol to be able to use whatever backend you want. But we provide a common interface so that our ecosystem libraries can hop on and update or change the request and response. Right? This is the Solid's. Let's see. Does the B2 docs have this stuff in here? If I go into reference docs. Use head. Yeah, so we also have head management now built in. It's technically Solid Meta wraps it as components to make it more usable, but use head is actually coming directly from Solid, fully stream capable, fully blocks on loading and like no flash on style content. We also fix flash on style content in dev because of that. Automatically, every Vite project benefits from it. File system routing. Did I not? This is the trickiest part now. Because yeah, it's because we added new exports that didn't get mapped directly into here, so I don't actually have them here. But there's some helper functions to set response and status and headers built into Solid Web now, and Solid Router has always kind of tagged on the request event so that it could like hang stuff like single flight data. I was getting kind of really annoyed at like how everything was getting slotted into these pieces, and I was really afraid of fracturing. So yeah, I mean, I don't know how to split these points. I think this is kind of where the challenge comes in. Like, is it now time to talk about Solid Start? I mean, TanStack Router still has really good types. It's the best TypeScript router ever to date. TanStack Query has caching protocol. We don't have a caching protocol. Solid Router's cache is simple. It basically says when you're moving forward, use a cache to dedupe, make sure you're not overfetching. When you're doing new navigation, when you're using the browser back and forth, we'll keep the cache a bit longer. So there's like a back cache, but it has no caching policy. It's not designed to be used as a cache. It's designed to emulate native browser behavior. I don't get use server needs to be frame for not separate. Well, if you want to control, here's the thing: server functions, server components are why largely. It's kind of the hidden piece here, which we haven't talked about, and we're not really talking about today. Though, if you look hard enough, you'll find them, and you can actually already use them, and they're actually kind of crazier than any server component solution to date. And we're not done yet, but that's a whole other thing. There's more to the protocol than just on the surface is what I'm getting at. And like like single flight mutation, and